As we begin our study of electricity, we will cover the following topics in this section. You will get to know the difference between the different types of charges, positive, negative, and neutral. You'll have a basic understanding of how charge is transferred from one object to another. You'll be introduced to the law of conservation of charge. You'll know the difference between conductors and insulators. You'll know how charge polarization works. And all of this leads up to an overall model of charge. Let's begin. Here we have two plastic rods that have been rubbed with wool. As I bring the rod in my hand closer to the rod that is hanging, you can see that it is repelled. A similar thing happens with two plastic rods that have been rubbed with silk. As I bring the rod in the hand close, the other rod is repelled. Now let's see what happens when I switch up the rods that I'm holding in my hand and I approach each of the hanging rods. As you see, now each of the rods are attracted instead of being repelled. We will say that a plastic rod rubbed with wool has a negative charge and a glass rod rubbed with silk has a positive charge. And we can see that in these two conditions, different things happen. This gives us our first observation about charges, that opposite charges attract and like charges repel. In this first example, I don't bring the rod too close to the hanging rod and it barely moves. Then I bring the rod much closer to it and you can see that the force pushing it is greater. This leads us to our next observation, that the electric force is inversely proportional to distance. The closer you get, the greater the force. The further away, the less the force. This example is pretty straightforward. Two rods will obviously push stronger than one rod, which gives us the observation that electric force is directly proportional to the magnitude of the charge. So let's go back and look at this wool and plastic that I used to rub together to create a charge. Before I rubbed them, the wool and the plastic had a neutral charge. Now, neutral charge does not mean that there are no charges within the object. It just means for every positive charge, there's also an electric charge. So here you see that the wool has 8 negative charges and 8 positive charges, and together that equals a 0 charge. Likewise, the rod has 3 negative charges and 3 positive charges, and that equals a 0 charge. This brings us to our next observation. A neutral object contains equal amounts of positive and negative charge. Now let's rub the wool across the plastic rod and see what happens. As you can see here, 3 of the negative charges have been transferred from the wool cloth to the rod, leaving the wool with a positive 3 charge and the rod with a negative 3 charge. However, when we are drawing diagrams, we don't include all of the charges. Just the excess charges are shown. Now, if you'll notice, there were no charges that were created during this entire thing. They were just transferred back and forth. And this gives us the law of conservation of charge, that charges can be neither created nor destroyed. They are merely transferred from one object to another. Here we have the first part of our model for electric charge. Take your time and read through this. You will be responsible for the material shown. Here we have a negatively charged plastic rod that is brought close to a metal sphere. When this happens, the negative charges are transferred from the rod to the sphere. This is called discharging. In this example, we have 2 metal spheres that are connected by a metal rod. When I bring a charged plastic rod close to the first sphere, the charges within it transfer through to both spheres. The metal rod in the middle is a conductor. It allows the charges to pass through it quite easily. Now the metal rod between the 2 spheres has been replaced with a plastic rod. When the charged rod is brought close, the charges only travel to the first sphere. The plastic rod is an insulator. Now we have the second part to our charge model. Take a second and read through this material. You will be responsible for it. We can create an electric force even without touching. Here I bring a positively charged rod close to a neutral conductor. When I do that, the positive charges in the rod attract the negative charges in the sphere and repel the positive charges. This is called charge polarization. It is the separation of positive and negative charges in a neutral object caused by bringing a charged object near it. Notice that the same thing happens in reverse if I bring a negatively charged rod close to the sphere. The positive charges are attracted and the negative charges are repelled. In both cases, there is a slight attraction between the polarized sphere and the charged rod because of the closeness of the different charged particles. In other words, in this example, the positive charges on the sphere are attracted to the negatively charged rod. Polarization always creates an attractive force. We can charge a conductor through polarization, but insulators are a little different. For an insulator, the charges are not allowed to move freely through the object. So when I bring a charged rod close to the insulator, all of the molecules within the insulator rotate so that the like charges are being repelled and the different charges are being attracted. This still results in a small attractive force between the sphere and the rod. Here are a few conceptual questions. See if you can answer them. Click on Continue to move to the next part of the video and see the answer. That's it for this video. Now complete the following quiz.